Hello students, now in this video let us solve some more examples on homogeneous recurrence relation. We will solve them. So now let me write the question. Solve the recurrence relations. Now I will write these relations one by one here. Okay, so let us be first one. Okay, the Fibonacci relation. I had already taught you, this is a very famous sequence, Fibonacci sequence, and we have obtained its recurrence relation also. Fibonacci relation, AR is equal to AR minus 1 plus AR minus 2 with A0 is 0 and A1 is what? 1. This is given to us. Fine. Now, solution for this. The given Fibonacci relation is, what does that? It is AR equal to AR minus 1 plus AR minus 2. That can be written as AR minus AR minus 1 minus AR minus 2 is equal to what? 0. These are the terms of recurrence relation itself. So we will take them on left hand side. The right hand side will become 0, means it is a case of homogeneous recurrence relation. Fine. Therefore, now here k is what? 2. So I will start from alpha square. So characteristic root, the characteristic equation is, the characteristic equation is, what does that? It will be alpha square minus alpha minus 1 is equal to what? 0. Now, what are the roots of it? Now, its roots are 1 plus minus root b square minus 4ac is what here? It will be 5. 5 upon what? 2. You can use a quadratic formula here. You know that ax square plus bx plus c is equal to 0. That gives x is equal to what? Minus b plus minus under root b square minus 4ac upon what? 2a. This is a quadratic formula. You can use that. From using that I have been written this. Fine. Now here alpha will be 1 plus root 5 by 2 and 1 minus root 5 by 2. These are what? Distinct. Therefore, the characteristic roots are, therefore the characteristic roots are what they? Alpha is equal to 1 plus root 5 by 2 and 1 minus root 5 by 2 are real and distinct. Are what? Real and distinct. So characteristic roots alpha, these one are what? Real and distinct. Okay, why as they are real and distinct, therefore the homogeneous solution is, homogeneous solution is what? AR H, that is equal to A1 into 1 plus root 5 by 2 raised to R plus A2 into 1 minus root 5 by 2 raised to R. These are the what? This is the homogeneous solution. Now again, as the previous one, I will name it as star. We will find the values of initial condition and substitute them in a star. Okay, so we have what? A0 is equal to what? 0. So that gives here A1 plus A2. Now I had written it directly. Here R will become 0. So this is a base. Anything raised to 0 will become 1. Here also it will be 1. That's why I have written A1 plus A2 is equal to what? 0. Fine. Again, and what can we say? A1 is equal to what? 1. So that gives A1 into 1 plus root 5 by 2 raised to what? 1 plus A2 into 1 minus root 5 by 2 raised to what? 1 is equal to 1. Let me name it as equation number 1 and this as equation number 2. Here these equations we will get. Now 1 gives A1 is equal to what? Minus A2. So let us write here it as minus A2. Therefore 2 becomes. How does the 2 implies? It will become, this is minus A2 into 1 plus root 5 by 2 plus A2 into 1 minus root 5 by 2 equal to what? 1. Now we can take A2 common here. So A2 will be common. What does it gives? A2 into. Now this minus will affect on this. So it will be minus 1 minus root 5 by 2. And this will be plus 1 minus root 5 by what? 2. And that is equal to what? 1. Fine. Now this is what? Here I can write this is, here's denominator same. So 2 as it is. The numerator will be minus 1 and this is plus 1. This is minus 1, here minus root 5 plus 1 minus root 5. As such we will get. That is equal to what? 1. So here A2 is there. Fine. Now here this 1 and minus 1 get cancelled. So this will be A2 into what? Minus 2 root 5 upon what? 2. That is equal to 1. 2 get cancelled. So here I get A2 is equal to what? This root 5 will come on the denominator. So it will be minus 1 upon root 5. A2 is negative. So A1 will become positive from this. Okay. Therefore, A1 is how much? 1 upon root 5. And A2 is already we get. It is minus 1 upon root 5. So that gives star becomes. Star is our required solution. So star will become AR is equal to what? AR is what? 1 by root 5. It is 1 by root 5 into 1 plus root 5 by 2 raised to R minus 1 upon root 5 into 1 minus root 5 by 2 raised to R is the required solution. Is the required solution. Okay. Now let's solve the second example. The second one, suppose the relation is given to us. AR is equal to 2 AR minus 1 plus 3 AR minus 2 with A0 is 1 and A1 is 11. So now solution for this, the given recurrence relation is AR, this is 2 AR minus 1 on right hand side. So let me take that one on left hand side. So minus 2 AR minus 1, again minus 3 AR minus 2 is equal to what? 0. Therefore, the characteristic equation is what does that? It will be alpha square minus 2 alpha minus 3 is equal to what? 0. That gives alpha minus 3 into alpha plus 1 as the factors. So that will be alpha is equal to what? Minus 1 and 3 are the real and distinct characteristic roots. Okay. Therefore, the homogeneous solution is what is that? It will be AR H, that is equal to A1 minus 1 raised to R plus A2 3 raised to R. Now A0 is equal to 1. So this star becomes gives what? A1 plus A2 is equal to what? 1. And A1 is what? 11. And A1 is 11. So again star becomes what? Here minus A1 plus 3 A2 is equal to what? 11. Solving these equations, we get A1, here we get A1 is equal to how much? Minus 2, and A2 is what? 3. You can solve it using elimination method. It is very easy. A1 has opposite coefficient, so we can easily add them and find A1 and A2 once we get them. Therefore, the required solution is what? AR is equal to what? Minus 2 into minus 1 raised to R plus 3 into 3 raised to R. This is our required solution for this given recurrence relation. Now, next example. Let me take the next example. Third, suppose AR minus 20 AR minus 1 plus 100 AR minus 2 is equal to what? 0. So solution with A0 is equal to 1 and A1 is equal to what? 20. So here the given recurrence relation is what is that? AR minus 20 AR minus 1 plus 100 AR minus 2 is equal to what? 0. Therefore, the characteristic equation is alpha square minus 20 alpha plus 100 is equal to what? 0. That is alpha minus 10 square is equal to what? 0. That gives alpha is equal to what? 10, 10. are repeated characteristic roots. Therefore, the homogeneous solution is what is that? AR is equal to what? A1 plus A2 R into 10 raised to R. Okay. Now, again use initial conditions to find A1 and A2. So, here A0 is equal to 1. So, that gives A1 is equal to 1. You can check it. Here 0, so A2, this part will become 0. 10 raised to 0, so it will be 1. A1 is equal to this. Fine. And A1 is equal to 20. So that gives A1 plus A2 into 10 is equal to what? 20. So that is A1 plus A2 is equal to what? 2. Therefore, now solving these one, we get A1 is equal to 1 and A2 is equal to 1. Therefore, the required solution is what does that? AR is equal to 1 plus R into 10 raised to R. This is our required solution for this one. Fine. Now, let's take the next one. The next equation is root of AR is equal to root of AR minus 1 plus 2 root of AR minus 2 with A0 equal to A1 equal to what? 1. So, solution for this. The given recurrence relation is root AR minus root AR minus 1 minus 2 root AR minus 2 equal to 0. So, now put SR is equal to root AR. So, SR is root AR, then root AR minus 1 will be SR minus 1 and root AR minus 2 will be SR minus 2. Okay. Then the recurrence relation will become SR minus SR minus 1 minus 2 SR minus 2 is equal to what? 0. Fine. Therefore, the characteristic equation is what? Alpha square minus alpha minus 2 is equal to what? 0. That gives the roots or the factors what they? Alpha plus 1, alpha minus 2 is equal to what? 0. That is alpha is equal to minus 1 and 2 are real and distinct characteristic roots. Real and distinct characteristic roots. Therefore, the homogeneous solution is Therefore, the homogeneous solution is, what is that? AR H, that is equal to A1 into minus 1 raised to R plus A2 into 2 raised to R. Now, is equal to what? 1. So, A1 plus A2 is what? 1. And A1 is equal to 1. That gives minus A1 plus 2A2 is what? 1. Solving these equations, we get, solving these equations, we get A is equal to 1 by 3 and 2 is equal to what? 2 by 3. Therefore, the required solution is AR is equal to 1 by 3 into minus 1 raised to R plus 2 by 3 into 2 raised to R. As such, we can solve the homogeneous recurrence relation. Okay. Now, here we will stop. In next video, we will see some more examples, but that are having with that have more the degree. Here we have taken all the characteristic equations of degree 2. In next one, I will take the examples of degree 3 also. Okay. Thank you.